So one more with the same picture as last time. A parabola that's crossing at 0 and 2 on the x-axis. And if I were to substitute in the middle, it would be a 1. So that would be -1 and a +2, so that's a y value of 1. Right there. So its vertex is at 1, 1. And this time rotated about the line y equals 1. So we would need the representative rectangles going this way. So that it's between the two functions. And then we've got that the rectangle is not parallel to the axis of rotation. That means this actually is not going to be a cylindrical shell. So this is instead either the disk or washer method. So for that method, we need to know, well, what's the bigger radius? So go from the axis of rotation all the way to the farthest away function. So that's going to be the bigger radius. And then go from the axis of rotation to the closer function, and that's going to be the small radius. And with the disk or washer method, the idea is you integrate pi times the big radius squared minus the little radius squared. D whatever variable you're going to be using. And in this case, the rectangle has to move back and forth between 0 and 2, so it's going to be dx. Okay, so we've got integrate pi. The big radius is going to be from up here down to there, so that's a length of 1. And then the little one is this little gap right here. Well, at the top, it's at a height of 1. And at the bottom, it's at the height of a parabola. So the length of this gap is the top number minus the bottom number. So the length of the gap, or the radius, is going to be 1 minus the parabola. Okay, so that is the little r. Then the little r needs to be squared. And then we need that parenthesis and dx, and x going from 0 to 2. So this needs some serious algebra. That's going to be a 1. Then I need to simplify all of this part first before I square it. So let's see, that's going to be, that's that negative sign, and then parentheses, 2 negatives makes a positive x squared, and then negative on that, and then this one is positive. And then I need to square that. Or over here in the scratch paper, I could say x squared minus 2x plus 1 times x squared minus 2x plus 1, and sort of use long multiplication, reminding me of 3rd grade. So take the 1 and multiply it with these 3 guys. Take the negative 2x and multiply it with these 3 guys. And take the x squared and multiply it. And then combine like terms, so there's a 1 over there, there's negative 4x's, there's 1, 2, and 4 more is 6x squared, or negative 4x to the 3, and then x to the 4. Okay, then it's 1 minus that. So the pi, I'm just going to factor that out of the way. So it's 1 minus all of this stuff. Well, when we get to the 1 minus the 1, they're going to cancel. Otherwise, this is just going to change all of those signs. So we're integrating negative x to the 4th, positive 4x to the 3, negative 6x squared, and positive 4x. Wow, now we finally get to do some calculus. So the antiderivatives are going to be negative x to the 5 over 5. Oh, this one is going to be x to the 4 over 4, but then the 4's are going to cancel. This would be x to the 3 over 3, but that will divide into that 2 times. And then x to the 2 over 2 also simplifies. And then thank goodness for the 0, because all of those are going to be 0, so that contributes nothing. We just need to figure out what about the 2. So 2 to the 5th, 1, 2, 3, 4, 5 of them, that would be a 4, and a 4 makes 16, times 2 is 32. So negative 32 over 5 plus 16 minus, this would be 8 times 2 is 16. And this would be 4 times 2 is 8. So we've really got those gone, and then 8 minus 32 fifths. So that would be 40 minus 32. So 40 fifths minus 32 fifths, 8 fifths.